Next section deals with how our muscles respond to things, what stimulates them, how do they work. One method of studying muscle function is to take a single fiber and then we look at electrical stimulation. The threshold stimulus then is the minimum amount that is needed to make a muscle fiber work. So threshold is that minimum. It's the least amount needed to generate an impulse that goes through the muscle, causes the calcium ions to move, the cross bridges to work, and then the muscle to actually contract. So in order for your muscle to contract, there is a minimum amount of stimulus that is needed for that to happen. So what they have done is they have taken and they can record the electrical impulses. So my daughter Bailey tore her ACL, and when we went to the field house at the Pentagon for one of the tests that they do, they hook you up and they can measure the strength of your muscle with these electrical impulses to see if it's normal, to see if it matches the other one. So what they do is they take these impulses and they make a myogram. So when a muscle fiber responds to an impulse, that's called a twitch. So when one muscle fiber responds, that's a twitch. We can record that on a myogram and see all of the muscle contractions. When we look at that, there are different steps. So the latent period, there's a little delay between stimulation and the contraction. So the latent period is that brief spot before the muscle actually contracts. Latent period is followed by contraction, relaxation. After a muscle contracts, it needs to relax or it will enter a cramping stage of permanent contraction. So here, time of stimulation, so if you're doing physical therapy, something like that, that might be when the coach or the athletic trainer pushes the button. There's a short period of time before it actually picks this up. Here's the period of contraction, the muscle is working. Here's the period of relaxation. When a muscle fiber contracts, this is important, you should know this. All or none response, everybody should know that. When a muscle fiber contracts, it contracts. There's no halfway, it contracts a little bit. It either fully contracts or it does not contract at all. So what happens, I'll talk a little bit now, but we'll talk about it more later. If I'm picking up something very light, I have thousands of muscle cells, muscle fibers in my biceps. If I'm picking up something light, a few of these fibers are completely contracted. If I go to pick up something heavy, I'm lifting something very heavy, then more fibers are going to be contracted. So all or none, a muscle fiber is either going to fully contract or it's not contracted at all. There's no in between. Muscle fibers do vary in their speed of contraction. There are slow twitch fibers and fast twitch fibers. Fatigue resistant, so these are going to last a longer period of time. These don't. People naturally have more slow twitch or fast twitch. If you are a sprinter and you are naturally gifted in that area, you probably have more fast twitch fibers than another person. And that is just something that's genetic. Muscle fiber is going to get stimuli, and then that stimulus is going to reach the point when it's unable to relax, and that's called a summation, so it's building up and building up. If that sustained contraction lacks relaxation, it's called a tetanic contraction. Tetanus, when you get your tetanus shot, if someone actually has tetanus, their muscles will harden or not harden. They will enter a form of contraction and not relax. More common in animals than humans because we typically update our tetanus shots to prevent this. But animals, we have sheep, and if they get tetanus, their bodies will just be stiff as a board. Their muscles are completely contracted and they can't relax. So that's called a tetanic contraction. And that's going to increase the force of contraction of a single muscle fiber. That is not something that you want. So if I look at a normal myogram, my muscle's going to contract, relax. That's what we want to happen. Here, maybe if I'm lifting something heavier, a little summation, work a little harder, but then eventually it's going to relax. If I have a tetanic contraction, notice there's no relaxing. It gets up to the top and there's no spot where that muscle relaxes. So here, this is getting back to the all or none part. A motor neuron and the muscle fiber it controls make up a motor unit. So that would be the muscle and the nervous system part. When stimulated to do so, those fibers are going to contract at one time. An increase in the number of those motor units within a muscle will give you higher intensity of muscle contraction. That is called recruitment. So recruitment is going to give you more strength. So like I said, I might have a few fibers working to pick up a pencil. If I'm going to pick up a table, they are going to recruit more units, more motor units. I'm going to have more muscle fibers working, and that's how I increase my strength. They recruit more muscle fibers. That diagram, I'm not interested. You can just skip that one. So summation and recruitment together can produce sustained contraction of increasing strength. Muscle tone is a natural continuous state of contraction of a few motor units. So, and my kids make fun of me, but I like track, I like to run, I love nice muscular legs. And you can tell in muscle tone, that is something that you naturally have. So muscle tone in your body, those are muscles that are in a continuous state of contraction. There's not a large amount. It's not going to hurt your muscles or be like a tetanic contraction. It's just a normal continuous state. Also very important for posture. Obviously, if my posture is not that good, but if your back muscles and your shoulder muscles did not contract, if they totally relaxed, you would have no posture whatsoever. So muscle tone is important for posture. And then you notice here again, it's genetic. Some people have more muscle tone than others. And everybody has muscle tone. I am an older person. A lot of my muscle tone is covered up with fat tissue, so you don't see it. So that is something that everyone does have. And that's where we will completely stop for today.